Hi everyone, welcome to Vin's workshop. Today we practice on solving quadratic equation by quadratic formula. So first of all, let's talk about what is quadratic formula. So they say that the solution of an equation ax squared plus bx plus c equal to 0 with a not equal to 0 are given by the following formula. We have x equal to the negative b plus and minus square root of b squared minus 4ac over 2a, 4ac over 2a. Okay, my suggestion for this one is pause the video a few minutes, learn the formula. You need to remember the formula, write it maybe 10 times, 20 times until you learn it by heart. Okay, because we're gonna learn how to apply the formula to solving the quadratic equation. If you don't remember the formula, it's really hard to solve it. And another suggestion is anytime you solve the problem, write the formula again. Just keep writing. That will create a habit. When you solve the problem, it will click right away the formula. Alright, so that's the formula we have to remember. So let me box this. That's the one we need to remember. Okay, and then let's go over example 1 to see how do I apply the formula to solving this. So we have example 1, we have 2x squared minus 3x minus 5 equal to 0. So we have 2 is my a, this is a, and negative 3 is my b, and negative 5 is my c. So my next step is write them out, list them all out. So a is 2, my b is negative 3, and my c is negative 5. By the formula we have x equal to negative b plus and minus square root of b squared minus 4ac over 2a. Make sure when you put the fraction line, it have to include the negative b. And if you can, try to practice write the square root with the hook at the end to tell me that, or to tell your teacher that that is ending of the square root. Now we plug them in. I plug in b by negative 3, then we have negative b is negative 3 plus and minus square root of b squared, so that would be negative 3 squared, negative 3 squared, minus 4ac, minus 4, my a is 2 and c is negative 5, so we plug in 2 and negative 5. Okay, and we need to extend the square root longer, which includes the whole thing, over 2a, so over 2, a is 2, so I plug in a by 2. Then we calculate them, we compute them. Negative times negative give me positive 3 plus and minus square root of negative 3 squared give me positive 9 minus 4 times 2 times negative 5. So first of all, negative times negative is positive. 4 times 2 is 8, times 5 is 40. Then over 2 times 2 is 4. Okay. I make my square root a little bit long. Let me cut it out. There we go. Alright, so my square root stop right here. Now we need to calculate them or compute them again. 3 plus and minus square root of 9 plus 4 is 49 over 4, which means 3 plus and minus 7 over 4. Plus and minus 7, that will break this problem at two cases. First one, x equal to 3 plus 7 over 4. And the second case is x equal to 3 minus 7 over 4. So the first one, 3 plus 7 over 4, which means it's 10 over 4. If I reduce it by 2, we have 5 half. The second one, 3 minus 7 over 4 will give me negative 4 over 4, was equal to negative 1. And that is our answer for example 1, is 5 half and negative 1. Alright, let's go over one more example to make sure we understand how to apply the formula. So I still keep the formula on the top right here so that we can double check back and forth to make sure I apply the correct formula. So here we go, and one more time, make sure you remember the formula, okay? So before in example 2 we have x squared plus x equal to negative 1. Before we get into solve this one, we need to write in the right form. They have to be in the standard form, whereas it should be ax squared plus bx plus c equal to 0. We want the 0 on the right side, which means that I have to move the negative 1 to the other side. So add 1 on both sides. Then we will have x squared plus x plus 1 equal to 0. By writing this way, I can find out my a, b, and c. So the number in front of x squared is 1, and also the number in front of x is 1. So my a would be a is 1, and b is 1, and c is also 1. Interesting. So we have a is 1, b is 1, and c is also 1. Now let's write the formula out. Again, make sure you write the formula every single time you solve the problem. So negative b plus and minus square root of b squared minus 4ac over 2a over 2a. So since we have a is 1, b is 1, c is 1, so I just plug them in. So b is 1 plus and minus, plus and minus square root of b squared, so which is 1 squared, minus 4ac, so minus 4, a is 1, c is 1, over 2a, so which means 2 times 1. 2 times 1. And that will give me negative 1. I may write too long. Negative 1 plus and minus square root of 1 squared is would be 1. Negative 4 times 1 times 1, so it's mean minus 4 over 2. And that equal to negative 1 plus and minus square root of negative 3 over 2. Negative inside of square root, that will be turned out at I, so we will have negative 1 plus and minus I square root of 3 over 2. Okay. And is pretty much it. We cannot go further on this one. And it's also one cannot add or subtract a imaginary number. So that's our answer with imaginary number. So Jack, I have 3 problems for you to practice on. So go ahead, work on them, have fun. If you get stuck, go back to the example, make sure you understand. Alright, enjoy everyone. You have 5 seconds to pause the video before we discuss about the solution. Alright. So I believe you have your answer already. So let's go over each problem and then see do we have the same answer or not. So problem 1, we have 3x squared minus 5x minus 2 equal to 0. So my a is 3, b is negative 5, and c is negative 2. So I prefer to write them out. A is 3, b is negative 5, and c is negative 2. Then again, when we solve the problem, make sure you write down the formula every single time so that we can remember the formula. So negative b plus and minus b squared minus 4ac over 2a. Okay, we plug in number. So we have negative, b is negative 5, so we need parentheses when you plug in the negative 5. Okay. Plus and minus square root of negative 5 squared. So we have negative 5 squared minus 4ac. So minus 4. A is 3 and C is negative 2. So plug in 3 and negative 2. Okay. All over 2a. So which means 2 times 3. Okay. Now we calculate this one. So negative times negative give me positive 5 plus and minus square root of 5 squared, negative 5 squared give me 25. Negative times negative give me positive. 4 times 3 give me 12 times 2 give me 24 over 6. Okay, so it will give me 5 plus and minus square root of 49 over 6. And square root of 49 is 7, so we have 5 plus and minus 7 over 6. And this problem will split. This step will be split down at two cases. So the first one is 5 plus 7 over 6, which give me 12 over 6, which is 2. And the second case is 5 minus 7 over 6. 5 minus 7 is negative 2 over 6, which is negative 1/3. So the answer for this problem is x equal to 2 and x equal to negative 1/3. So we have two solutions for problem 1. Now problem 2, so the same idea. A in this case, so keep in mind a is the coefficient. In this problem too, they use a also, the unknown, so don't mess up the information. We don't have any number in front of a, which means we always have 1 in front of the variable. So we have 1 is a, 2 is b, and 3 is c. So a equal 1, b equal 2, and c equals to 3. Since I don't have enough space, so I'm going to skip the formula part so that we have enough space for the solving part. So negative b, I plug in negative 2. Negative 2 plus and minus square root of b squared, so which means 2 squared, minus 4ac, minus 4 times 1 times 3. Okay. All over 2a, so all over 2 times a is 1. Here we go. So negative 2, negative times positive 2 is negative 2, plus and minus 2 squared will give me 4, minus 4 times 1 times 3, so minus 12 over 2. So that will give me negative 2 plus and minus square root of 4 take away 12 will give me negative 8 over 2. Since we have the negative inside of the square root, we will have I. So the next step is negative 2 plus and minus I square root of 8 over 2. Next step is, can we simplify the square root? So square root of 8, we can rewrite as 4 times 2. So square root of 4 give me 2, so this one will be rewrite as negative 2 plus and minus square root of 4 is 2, so we have 2i square root of 2 over 2. Then our next step, we can factor out the 2 and reduce it. So factor the 2 out, that will give me negative 1 plus and minus I square root of 2 over 2. Then 2 and 2 cancel out. Okay, so we have a common mistake right here. many of us, we will cancel out this 2 and this 1, which is totally wrong. We just cancel them out when they in the product form, like the last step I'm cancel out right here. So let's go back to this step. So we just reduce 2 when they in the multiplication form, the product form. So the answer for this problem is, the final answer for this problem is -1 plus and minus I square root of 3, and we have imaginary solution. We have imaginary solution. Now one more time with problem 3, we have 4x squared plus 12x plus 9 equal to 0. So we have a is 4, b is 12, and c is 9. A is 4, b is 12, and c is 9. Now we can apply the formula. So x equal to negative b. So negative b is 12, so negative 12. Plus and minus square root of b squared. So we have 12 squared minus 4ac. So minus 4. A is 4 and c is 9. So 4 times 9. Okay. All over 2a. So all over 2 times 4. So we have negative 12 plus and minus 12 squared give me 144. Negative 4 times 4 is negative 16, times 9 is another negative 144, over 2 times 4 is 8. So we have negative 12 plus and minus square root of 0 over 8, which give me negative 12 over 8. Square root of 0 is 0, so when you add or subtract 0 is nothing, it still be itself. So negative 12 plus or minus 0 is still negative 12. And with this problem, we can reduce by 4. That will give me negative 3 over 2. Reduced by 4, we have negative 3 over 2. So the answer for this problem is, for problem 3, is only one solution, x equal to negative 3 over 2. Okay, so we have 3 examples with 3 different types of answer. Example 1 let you know that, or show you that we have 2 solutions. Example 2 show you that we have imaginary solution. And example 3, surprisingly, they give you 1 solution. So why we have that's different? So the idea, or we can pick up from on the way we solving the problem, is we have 2 solutions when the term inside of the square root, when it's a real number. If the square root give you the real number, we have 2 solutions. If the square root, the term inside is negative, will give you imaginary number. So if the one inside is negative, that will give you imaginary number. Negative. Okay, and if the term inside is 0, then you have only 1 solution. Okay, so the next section we will talk about this one. The concept to recognize this, they call discriminant. So we're gonna talk this in the next second. Now let's talk really quick about discriminants. So as we see that the quadratic formula is x equal to negative b plus and minus b squared minus 4ac over all over 2a. Based on the previous subject, we learned that if the term inside of the square root is positive, you have 2 solutions. If it's equal to 0, you have 1 solution, and when it's negative, you have imaginary solution. So let's write this one down. So if b squared minus 4ac greater than to 0, then you have, they call it 2 different real solution. So 2 different real solution. Different real solution. Solutions. Okay, and when is equal to 0, we will say that it's one repeated solution. So one repeated solution. Okay. And last one, when b squared minus 4ac less than to 0, then we have two different imaginary solutions. Two different imaginary solutions. Here we go. Okay, let's do a quick example on this. I believe we're on example 3 on this. So we have determine the number of solution. The equation. Okay, let's look at example 3. Determine the number of solution for the equation x squared plus x plus 1 equal to 0. So we don't solve for the solution, we just need to verify what is the solution is. We have two different real solution, one repeated solution, or two different imaginary solution. So we still need to identify a, b, and c. So we have to add the number in front of the variable. So my a is 1, my b is 1, and my c is also 1. A is 1, B is 1, C is 1 as well. So to solve this one, we're gonna use the discriminant property or formula. So we have b squared minus 4ac. So my b is 1 squared and minus 4. A is 1 and C is also 1. We will have 1 squared is 1 minus 4 times 1 times 1 is 4. So the answer is -3. Since -3 less than to 0, so we will have two different imaginary solutions. Two different imaginary solution. So basically, we just need to apply a part of the quadratic formula to figure out how the solution look like. So that's pretty much it. Now let's talk about non-quadratic equations. So in example 4, we have x to the 4 minus 3x squared minus 4 equal to 0. And you see that this problem is not like usual. It's not like x squared minus 3x minus 4. Right now it's x to the 4. So we try to bring this problem back to the usual by use the substitution. So here the idea we're gonna do is let any variable, I will use u. Let u equal to x squared. I set u equal to the middle term if your equation in descending order. So we let u equal to the middle term. Then we will have u squared. If I square on both sides of the u, so we will have this x squared will give me x4. Would tell me that u squared equal to x4. Would tell me that u squared equals to x4. Then we back substitution. X to the 4, x4 will be replaced by u squared. So we have u squared minus x squared. As you see, last time we set u equals to x squared, then this x squared will be replaced by u, so 3u minus 4 equal to 0. I know the problem is a little bit confusing because it's go back and forth between the power. So here the idea, pick the middle term, set u equal to the middle term so that we replace the middle term by u squared. Then the first term, when you square both sides, that will be equal to u squared. That's what we try to do. We try to write them in the quadratic way, the usual way. First term square, subtract the second term in the first power, and subtract the constant. Now we can solve this one by any method, by quadratic formula, or we can also use the factoring form. So I'm gonna solve this one by factoring. So I draw the x. First number times last give me -4. The middle term will be -3. We will find a pair with multiply give me -4 and add up give me 3. So that pair is 1 and -4. Let's check this. 1 add -4 give me -3, and 1 times -4 give me -4. That's perfect, and that is our solution. So solution is u plus 1 times u minus 4 equal to 0. We split them up, so we have u plus 1 equal to 0, or u minus 4 equal to 0. Then we keep going, solve for u. So minus 1 on both sides, u equal to -1, plus 4 on both sides, so u equal to 4. But the problem they give us is not u, they give us is x, so we have to solve for x. Last time we say that u equal to x squared. Last time we said u equal to x squared, which means this u will be replaced by x squared. Draw the line is this u will be replaced by x squared. So x squared equal to -1. We can solve this. We can get rid of the square by square root on both sides. So we will have x equal to plus and minus -1 inside of the square root, so it would be I. And on this side, we do the same thing, u equal to x squared, so we can replace u by x squared equal to 4. Then square root on both sides. We will have x equal to plus and minus 2. So we have the total is 4 solutions, 2 real number and 2 imaginary number. Okay, I know the concept is quite hard, so you may want to pause the video and look at the problem a couple minutes to make sure you understand the concept, and then we move on to example 5. You will see the concept repeat again, and that may help when you compare back and forth two examples. So let's go over example 5. So we try to bring this big problem back to where is the u squared something u and constant equal to 0. So you know the idea. We're gonna do is let u equal to this one already in descending order, because you have square here, you have first power here. So we set u equal to the middle term, so this is 4t plus 2. Then when we square both sides, so u squared equal to 4t plus 2 squared. And you see that 4t plus 2 squared, this guy will be replaced by u squared. So we have u squared minus 30. This one, 4t plus 2, is where we set it equal to u, so that would be negative 30u plus 224 equal to 0. Now, again, you can solve this problem either complete on the square or quadratic formula. So it's up to you. So I'm gonna solve, since I solved it by factoring before, so I'm gonna solve this one by quadratic formula. So we have x equal to negative b plus and minus square root of b squared minus 4ac over 2a. So we have a is 1, b is negative 30, and c is 224, positive 224. Now we plug them in, so we will have negative b is negative 30 plus and minus square root of b squared is negative 30 squared minus 4ac, so minus 4 times a is 1 and c is 224. Okay, all over 2a, so all over 2 times 1. So negative times negative give me positive 30 plus and minus. Negative 30 squared give me 900 minus 4 times 224 will give me 896 all over 2. That will give me 30 plus and minus square root of 4 over 2. So we have 30 plus and minus square root of 4 is 2 over 2. This one will break down at two cases. The first one is 30 plus 2 over 2 will give me 32 divided by 2 is 16. And the second case is 30 minus 2 over 2 will give me 28 over 2, so which is 14. Okay, so I need more space. I'm gonna erase on this side. Let me remind you this one. The formula is x equal to negative b plus and minus square root b squared minus 4ac over 2a for the equation ax squared plus bx plus c. But the problem we actually dealing with is u. Okay, so which tell me that this variable is not right. This one should be u equal to that one, equal to that solution. So we will have u equal to positive 16 or u equal to 14. Again, we use the letter u because the variable we're dealing with is u. Okay, and we did set u equal to 4t plus 2. So back substitutes, we have 4t plus 2 equal to 16. And we solve through. So minus 2 on both sides. We have 4t equal to 14 and divide by 4 on both sides. T equal to 14 over 4. So we reduce by 2, give me 7/2. Or is approximate is 3.5 is the decimal point. So which can be rewrite as 3.5. Here we do the same thing here. U will be rewrite as 4t plus 2 equal to 14. And we solving for t. So subtract 2 on both sides. 4t equal to 12. And we divide by 4 on both sides. T equals to 3. That is my second solution. So we have two solutions for this one when t equal to 3.5 or 3 equal to 3. T equal to 3. So I know the substitution method is a little bit confusing, but you need to get it because the problem is will be harder and bigger. So try to go back to the example a couple of times. Make sure you understand the concept. Things will get easier when you practice a lot. Okay. Alright, I have 3 problems for you to practice on. Go ahead, work on them. Make sure you understand the concept. And let me give you some idea how to solve this. First of all, you need to write the equation in descending order, which means you have to move everything on one side, set it equal to 0. Then the highest power will be the first term and the middle power will be the middle term. Last one will be the constant. Okay, then let u equal to the middle term. Alright, so let's try on this one. Try your best. Have fun and enjoy them. If you get stuck, go back to the example. You have 5 seconds to pause the video before we discuss about the solution. So I believe you have your answer already. So let's go over this one. Um, Problem 1, we have x plus square root of x plus square root of x minus 6 equal to 0. So as you see that x is raised to the first power, square root of x is basically 1/2, which means they already write the equation in descending order. So our job is let u equal to square root of x. Then my u squared will be equal to square root of x squared, which give me x. Then we see that this x right here equal to u squared, so we will have u squared plus square root of x is equal to u, so plus u minus 6 equal to 0. Then we solve this quadratic equation by either one, any method. So I'm going to use this factoring. So draw the x, negative 6 and 1. The pair which work for the diamond form is 3 and 2. 3 and 2 with the negative at 2. So we have the answer is u plus 3 times u minus 2 equal to 0. Then each of them will be equal to 0. So we have u plus 3 equal to 0 or u minus 2 equal to 0. So we solve for u, minus 3 on both sides. We have u equal to negative 3. Now we do back substitution. U equal to square root of x. So square root of x will be equal to negative 3. We replace u by square root of x. Then to get rid of the square, we have to do is, to get rid of the square root, we have to do is square on both sides. Then we have x equal to positive 9. Then we solve on this side. To set u by itself, we add 2 on both sides. So u equal to positive 2. Back substitute, u equal to square root of x. So I replace u by square root of x equal to 2. To get x by itself, we have to do the same thing, square on both sides. So we have x equal to 4. Okay. I don't have time to check the solution, but you should plug them in and check it. You will see one of them is extraneous solution. And let me point out here is this guy, x equal to 9 is extraneous solution. When you plug them in, you will see that they won't give you the correct answer. And x equal to 4 is another solution, is a solution. This one I recognize this is extraneous solution because since you have square root of x equal to negative 3, so x square root of x always give you a positive solution. It cannot equal to a negative one. Square root of x always give you positive answer, not equal to a negative number. So that's why I see that it's extraneous solution, but we can also find out by plug them into original equation and check is that a correct solution or not. So let's go to example 2. So it's the same idea. Example 2, we have 2m raised to 2/3 minus 2 equals to 3m 1/3. So as we say that we have to set them equal to 0, so I need to move 3m 1/3 to the other side. So subtract 3m 1/3. I write down 1/2, it should be 1/3. Okay, so the problem will be rewrite in descending order. So we have 2m raised to 2/3 minus 3m raised to 1/3 plus 2 equal to 0. My bad, minus 2 equal to 0. Minus 2 equal to 0. Now, since it's already in descending order, so we let u equal to m raised to the 1/3. So u squared will be equal to m raised to the 1/3 square, give me m raised to the 2/3. So the concept repeat. m 2/3 will be replaced by u squared. So 2u squared minus m 1/3 will be replaced by u. So minus 3u minus 2 equal to 0. Then we solve this by factoring. So I will use the diamond form again. 2 times negative 2 give me negative 4 and negative 3 at the bottom. The pair which work on this case is 1 and negative 4. So 1 at negative 4 give me negative 3. 1 times negative 4 give me negative 4. So this is the correct diamond form. So our answer will be u plus 1 times u minus 4 equal to 0, and we set each of them equal to 0. U plus 1 equal to 0, or u minus 4 equal to 0. So solve for u, we minus 1 on both sides. U equal to negative 1, and we add 4. Let's finish this one. I shouldn't come to that. Let's finish one equation at a time. So my u will be replaced by, we set m equal to 1/3, m raised to 1/3 equal to u, so we back substitute. M 1/3 will be equal to negative 1. Now to get rid of the 1/3, we have to do is raise to the third power on both sides. Raise to the third power on both sides. So that 3 times 1/3 will be cancelled out, give me m raised to the first. So basically it's just m equal to negative 1 raised to the third power is negative 1. So that is my first solution. Okay, let's go back to the second equation and solve it through. So add 4 on both sides so that u equal u by itself. So u equal to 4. Back substitute u by m 1/3. So m 1/3 equal to 4. Then we raise to the third power on both sides. So 3 and 3 be cancelled. Give me m equal to 4 raised to the third power is 64. So m equal to 64 is my second solution. Okay. So u plus 1 times u minus 4 equal to 0 is almost the factor of this trinomial. It's not yet, because u times u give you u squared. They don't give you 2u squared. So if you're watching my video before, I'm gonna factor this one by divide by the leading coefficient. So we divide by 2 on both sides. 1/2 in lowest term, so we just need to bring 2 in front. And 4 divided by 2 is evenly 2 times. So we will have the completely factoring is 2u plus 1 times u minus 2 equal to 0. Then we split them up. 2u equal to 2u plus 1 equal to 0, or u minus 2 equal to 0. Then we solve for u on each side. Since we're gonna out of space, so I will do a shortcut here. So subtract 1 on both sides, you will have 2u equal to negative 1, and divide by 2 on both sides, so you have u equal to negative 1/2. Then we do back substitution. U will be replaced by m raised to 1/3. So m raised to 1/3 equal to negative 1/2. Then to get rid of the third, we have to raise to the third power on both sides. Raise to the third power on both sides, so that 3 and 3 will be cancelled out, give you m by itself. And negative 1/2 raised to the third power, negative 1 raised to the third is negative 1. 2 raised to the third give me 8. So negative 1/8 is my solution. Negative 1/8 is one of my solutions. Now we do the same on this side. So add 2 on both sides. We have u equal to 2. Back substitute u by m raised to the 1/3 equal to 2. Then we raise to the third power on both sides. Okay, raise to the third power on both sides. So that will give me m equal to 8. M equal to 8. So we have two solutions for this problem. M equal to -1/8 and m equal to 8, and that's the two solutions. Now in problem 3 we have 15 a raised to the -2 minus a raised to the -1 plus 1 equal to 0. So we do exactly the same concept. Let u equal to a raised to the first power, a raised to the -1, then u square equal to a raised to the -1 square, give me a raised to the -2. Okay, then we substitute them. So we will have 15 u squared minus 8u plus 1 equal to 0. Then we factor this by the diamond form. So we have 15 -8. So the pair which work is -3 and -5. -3 times -5 give me positive 15, and they add up give me -8. So our factoring will be u minus 3 times u minus 5 equal to 0. And again, since we have the leading coefficient is 15, so we have to do it divide by 15 on both sides. So if I reduce this, 3 go to 15 is 1/5, and 5 go to 15 is 1/3, give me 1/3. So we have u minus 1/5 times u minus 1/3 equal to 0. Then we apply the concept I give you before, move 5 forward and move 3 forward. We will have 5u minus 1 times 3u minus 1 equal to 0. Then 5u minus 1 equal to 0, or 3u minus 1 equal to 0. Solve for u on each side, so you will have u equal to 1/5. Back substitution, u equal to a to the -1, a to the -1 equal to 1/5. So basically this to get rid of -1, we have to multiply by another -1, or raise to the -1 on both sides. So -1 times -1 give me positive 1, so which means a raised to the first power, or basically just a, 1/5 raised to the -1. So since they have the negative exponent, we have to flip it. So that will give me 5/1, or it's just 5. So the same idea on the other side, we will have u equal to 1/3, and back substitute, u will be replaced by a raised to the -1 equal to 1/3. Then we raise to the -1 on both sides. Raise to the -1 on both sides. So we will have a equal to 1/3. We flip it, give me 3/1, or just 3. So the answer for problem 3 is a equal to 5 and a equal to 3. That's the two solutions for problem 3. So I hope that I give you some idea how to solve non-quadratic equation by substitution. So the idea is really important. We're gonna use this a lot in this section. So hope that you can pick up the idea. It's not too hard. Just take some time, practice, understand the concept. You will be fine. All right. Let's go to the next section. So to close today's section, I have 9 problems for you to practice on. Make sure you understand the concept. If you get stuck, go back to the example and self-check. Um, so don't forget to write your equation in descending order and set them equal to 0. If you do with a decimal point, the only way to get rid of decimal point is multiply everything by 10, 100, or 1,000. It depends on you, how you see the problem, how you judge the problem to multiply with 10, 100, or 1,000. And when you do with a fraction, the way to get rid of fraction is multiply everything by the LCD. Okay, so I believe I give you enough information to solve those practice. So go ahead, try on them. Good luck. You have 5 seconds to pause the video before the answer show up on the screen. Okay, enjoy everyone. So answer up. I hope that we have correct answer. Um, the only thing I want to remind you is keep an eye on extraneous solution on problem 7. So if you master, if you proficient of all the concept, you probably need to keep an eye on extraneous solution as well. That is the weakness. And if I am your teacher, I will test you on this one to make sure you know how to check your solution. And okay, as always, thank you everyone for watching the video and hope to see you in the next one. All right, bye bye.